This is our robotic arm with computer vision, and we're going to demo it.
Object.
Searching out object.
There we go. I'm Amott,
I'm Jeff Marsh,
and this is our project.
the robotic arm using computer vision. So to kind of introduce our topic here, we have a robotic arm and a camera that is controlled by a Raspberry Pi, that's kind of the brains, and the camera and the servos all kind of work together software-wise to control the arm to grab an object.
So ROS is our main system, robot operating system. It's a main communication network that allows us to run different programs on different parts of the system, each doing their own thing and not depending on the other piece finishing its part. It allows us to kind of isolate different pieces of code and ensure that one piece works before the other works. And we don't break one piece in the process of fixing another.
So in order to do that properly, we need some sort of storage device, some brains behind it that we can hold our code in and run it. And so that's where the Raspberry Pi 4 comes along. And so we used that, like I said, as the brains sort of deal. And that allows for all of our components for our project to kind of mesh together and work completely independently from one another. And so it can see an object, and then it can tell the arm, okay, I see this object, and now I'm going to go pick it up.
This is Google's Coral. We use this for recognition of each of the camera's frames. The camera takes a picture of our surface and recognizes where on that frame the object sits. The Coral helps us recognize where the object is much more quickly than the Raspberry Pi can do on its own. It can take it down in a fraction of a second, whereas the Raspberry Pi takes much longer.
And so with the assistance of the wonderful Coral, we are able to kind of break up the load there. And so the Coral takes care of the OpenCV computing part, whereas the Raspberry Pi can take that, and then it can take that already solved math there and use it to talk to the servos. And so then the servos can interact there and go and actually move the arm to pick up that object.
The hardest part of this entire project was finding out the angles for each of these 6 servos. The base and the wrist reverse each other so that they stay consistent, and these 3 parts right here, each of them has to coordinate to make sure that the wrist, as we say, the hand, stays level so that it doesn't end up picking an object up sideways or incorrectly. It has to be able to coordinate these so that it can reach out far or pull in.
And so here we have kind of our general math that we did. We had to figure out, the distance of the actual arm itself, and then figure out every different angle that it could possibly be. So we had to figure out an equation to use to implement in our code so that it can do all of that math by itself, regardless of where the object is on the screen.
How we did that is we broke up each of the different joints and pieces into triangles. On the arm, for example, we could say that one triangle, the corner of the triangle is the elbow, one corner is the wrist next to the hand, and one is the base joint that lifts up and down. Once we know that triangle, we have to find out what angle that triangle sits from the ground, and we break it down into smaller and smaller pieces until we have all of the angles that we can add together to get the real angles of each piece.
And so to kind of conclude here, this was a difficult project, but it challenged us. It was really good because it helped us reach a new level than we were before. At least for me personally, this stuff was totally out of my league before, but now I actually understand how it works and I can implement it in future applications. And this project, this design can be used in many different types of robots, types of applications.
I agree with that. I had no idea how to use robot operating system, and I know no one who knew how to use it. But now that we've got this experience, we can document very carefully what we've done so far And we're hoping that future students of this class will be able to pick this up and continue to grow with it.
And that's our project. Thank you.